VLPSos here. This is a video lesson for Python programming, data type list. These videos are intended to be paused so that you can practice. I have 4 variables defined and assigned 4 different values. I have an integer, a string, a float, and a boolean. And we're going to add to this the new data type that we call list. An example of a list, we'll call a variable a list and assign it using the square parentheses and putting 3 elements inside of it. We've made this variable assigned to be a list. This is a list of length 3. It has 3 integers inside of it, and what define the list is the square brackets, the use of the square brackets. We can verify that this is a new type by putting a list into the type function and printing the result. Running and seeing what we get, we see that what got printed was what the interpreter is recognizing as a list type. Lists contain other data, which could be of any type. They have a length and may contain other lists. Lists may also be empty. I'm going to print the length of the list that I defined using the length function spelled len, and we can see that we put the list inside of it. If we run this, what's going to print is the length of the list, and a 3 got printed. That's because there are 3 data, well, there's 1 data type integer, but there's 3 representations or 3 elements that are that integer. 1, 2, and 3 separated by commas. I'm going to define another list. I'm going to call it blist. And I'm just going to use the square parentheses, which means that I've created a list, but there's nothing inside of it. If there was something in blist, there would be something inside those parentheses. And I can verify the length of blist by putting it into the length function and printing the result. And we can see that 0 is an acceptable length for a list. It's like having a string that has no characters in it. It is possible for these data types to be empty. But of course, we make use of lists by having and storing data inside of them. We can add to a list. In this case, I'm going to add to blist with the append function. So this is a method that I'm modifying the blist with. I use the name of the variable that represents the list, in this case blist, and then a dot in the append function. The append function requires something to be inside of its argument, and in this case that is what is going to go into the blist. I can print blist to C. And in the output, I can see that when the list got printed, it included the list parentheses. This is an unelegant way of printing the contents of the list, but it's fast, simply by putting the list into the print function. There's another method for adding to a list. I could refer to the list and then say that it is going to be reassigned to be itself plus another list that has something inside of it. In this line of code again, I'm reassigning to blist itself with the addition of another list. In this case, a 2 is inside, so it's going to add these 2 lists together and include the element 2 inside of blist. And when I run, I can see that now I'm reporting or printing that there are two elements inside of blist, the string new and the integer 2, which shows us that we can combine data types in lists. We don't need to have a list contain one single type of data. We can combine them. And we make a comment. Notice the things that were added did not need to be the same data type. Moving on, we can write conditions with lists. For example, if we create the condition with the keyword if, the conditional statement, and the condition being if the string new is in blist, again, this is the condition with the keyword in, so it's going to be true, the condition will be true if this string, very precisely that exact string, is inside of the list that's referred to. And we make the conditional statement with the if and the colon. If the condition is true, we will print the string new must be in the list. And when we check this, we should expect to see this print line because we chose a string that we had added or appended to the list in the previous code. And indeed, we see that line executed. Lists are very, very useful and helpful. Here's a clever way to use one. We've defined the list invites, and we have 3 strings, 3 names inside of our invites list. We can define another variable. I'm going to call crasher and assign it to be the string bad mojo. And then we can write a conditional statement. If crasher is not in invites, if this condition is true, then I'm going to execute the code block that I'm going to indent, and we will print sorry with the string symbol, and then supply the value of that symbol, which must be a string, crasher. When I anticipate what this code is going to do when we run, we have a list of, we could think of people that are on the invite list as if they're going to a party or an event, and we have somebody that is not on that list we call crasher. Our condition checks to see if this person, crasher, is in the list. And if they're not in the list with this keyword not in and referring to the list of invites, then it'll print using the name of that string that was not inside that list. We can imagine that this is checking to see if somebody has been invited to a party, and if they're not, the program notices and reports a message. We'll put a Y with sorry. Moving on, we can delete from lists. So if we refer to the list, in this case invites, we can append the remove function, or think of remove as a method that is going to modify the list. In this case, the remove method requires input, in this case the string that you want to remove. I'm going to spell it intentionally with a lowercase s, and we'll see what happens. We have an error, and we read our error report, list.remove, x is not in the list. So the input that we gave to the remove function was not recognized to be inside the list, and it caused an error since it didn't find it there. And indeed, this string has to match exactly a string in the invites list, and it does not because there's a capital S in the actual invites list. I could fix this by capitalizing the sauce. More importantly, we need to be careful about attempting to remove things from lists that are not there. Removing something from a list that isn't in the list will break your program, so it's usually a good idea only to remove with a conditional statement, like this. If Bad Mojo in invites. This is a conditional statement. Invites does not contain the string Bad Mojo. We already know that because we printed that fact that it didn't recognize Bad Mojo in the list. So if we tried to remove Bad Mojo from the list, it would break our program, which is why we have a conditional statement around it now. This code, the code that will remove Bad Mojo from the list, is only going to run if Bad Mojo was found to be in the list in the first place. So we're protected from trying to remove something that isn't there. I'm also going to add the print of the list here so we can see now that we've capitalized sauce if it's been removed. Let's check. So we can see that the list got printed and sauce must have been removed. We could also print the list here to confirm that Bad Mojo isn't in it, never was, and there wasn't an error. So the second line is to absolutely be certain that the program didn't break. We didn't see an error report, but it didn't break because it got to that line after it attempted to remove Bad Mojo on condition that Bad Mojo was in the list. And there is much, much more to say and do with lists. Soon we will learn about indexing, and we'll use them to iterate. Much more about lists in the future. Now you. Write a simple program that creates a list of your immediate family members, asks for a user to input a name, and then responds if the name was a familiar family member.